Okay, in this problem we're going to look at how to incorporate mu in the fun equation into our two-dimensional problems. So here we can see we have a block. It's being pulled by a force of 10 newtons. So this force right here is 10 newtons and it's up at an angle of 60 degrees. If the block is accelerating at 1 meter per second, we want to figure out what the frictional force is, the normal force, and the coefficient of friction between the surfaces. Alright, so first thing we always do is draw our free body diagram with all of the forces acting on it. Second thing is we write out our equations in each direction. So in the x direction, it is accelerating, and in the y direction, it is not accelerating. I have two forces left to right. I have the x component of the force applied, which we find by using the cosine of that angle, because it is the adjacent side. And I have a frictional force going the opposite way. Where did my A go? And that'll equal MA. Up and down I have three forces. I have the normal force. I also have the y component of the applied force. So since it is going up, I'm going to add it. And I have mg down. Okay. Process gets us to this point. Now we just look at what do we need? We need the frictional force. So I look in the x direction since that's where the frictional force is. I can manipulate that for the frictional force so that friction is equal to F times the cosine of theta minus MA. And if I go through, I know the value of the force is 10 newtons. I know the angle is 60 degrees. I know the mass is 2 kilograms, and I know the rate of acceleration. So I can plug all that information in. So that's the next line with all the numbers plugged in. And now we just use our calculator. If you know your unit circle, you know the cosine of 60 is half. So we have 10 times a half, which is 5 newtons, minus 2 newtons, because a kilogram times a meter per second squared is a newton. We can see that the frictional force is going to be a total of 3 newtons. Alright, we're going to need that later in the problem, but we're going to then solve for the normal force. Okay, I shrunk that, move that out of the way. I want the normal force in this equation, so I am going to rearrange. Alright, I'm going to move my mg to the other side so it becomes a plus, and move the f sine of theta so it becomes a minus. And this equation should read that the normal force is going to be this value less than the weight. And that should make sense because the normal force is how much force the surface pushes up. If we have another amount of force upwards, the surface doesn't have to push up with as much force as the weight, right? Because the normal force plus that applied force has to combine and equal the total force down. So the normal force upwards is going to be less than the weight because it's going to be this much less than the weight. Here's the next line with all of the numbers plugged in. And again, now it's just some buttons on a calculator. And again, plugging in, we know that the normal force is going to be less. It's going to be this much less than the weight. So we get the normal force is 10.9 newtons. Okay, so that's old news. We were able to do those before talking about friction. Now we have to figure out what the coefficient of friction is. Everything's all messed up. All right, get all this away. Throw it away. Don't need any of that. Just need this part and this part. So we're going to have to find the coefficient of friction. The only equation that has the coefficient of friction in it is our fun equation. So I want to know that. So rearranging this equation, mu is the ratio of the frictional force to the normal force, which is what we just found. So we have 3 newtons over 10.9 newtons, and what we can see is those units are going to cancel out. So the coefficient is really just a number. It has no unit. And we get a number of 0.275 as our coefficient. And remember, mu is almost always less than 1. So if you got the 10.9 over 3, you know you manipulated this equation incorrectly. Okay, there are instances where this might have to be done somewhere in between solving for the frictional force or normal force. You just got to figure out the correct path to take. But, I mean, that's using our new equation.